Virtual reality allows us to control and change what we see and hear through the pixels and speakers in a headset. In this project, we're exploring how VR's limitations can inspire an architectural device that creates sensations VR can't, like heat, cold, humidity, and spatial awareness. Initially, I researched structures that could change size. I guessed that controlling the volume of space would significantly impact environmental conditions. That's when I discovered the Chuck Hoberman sphere, and felt confident this was the right direction. However, during the TechSea project, we questioned whether a Hoberman sphere was feasible. The project focused on the technical design of a fragment of a building. We used both quantitative and qualitative testing. The theme of the fragment reflected my views on architecture. I believe buildings can be severely damaging to the environment due to the extraction and transportation of raw materials, as well as the construction, disassembly, recycling, and even landfilling. To address this, I decided to design something that resembles a building, but minimizes the need for new materials. I envisioned a temporary pavilion using primarily existing local building infrastructure. We focused on three main testing strategies: climatic performance, building life safety, and constructability. I looked at how different volumes of space affected cooling rates, the amount of structure needed to withstand lateral forces, and a construction method that required minimal training and precision. Given its temporary nature, ease of construction and deconstruction was a priority. As we moved from strategy to tactics, I realized the feasibility of a Hoberman sphere was becoming questionable. Tactics involved the materials, tools, and processes needed to carry out our strategy. In considering reusable, conveniently located temporary building materials, I settled on scaffolding. However, the complexity of a Hoberman sphere really stumped me. I realized I needed a simpler idea. Instead of a frame that could expand and contract with a fabric to change space, I considered a static frame with the fabric itself moving. Next, I needed to test whether changing the fabric's radius within a frame could alter the environment. My prototype reflected the form I wanted to investigate. The variable was the radius of the fabric in tension, and I examined how quickly different radii cooled down. I initially expected the larger radius to cool the fastest because of the airflow. However, I overlooked the fact that a bigger radius held more air, leading to greater thermal mass. Instead, I found the largest radius took the longest to heat up and cool down slower than the smaller radii. After prototyping and testing, I returned to the architectural fragment. Drawing inspiration from my prototype, I worked on how the simple scaffolding frame and fabric elements would function on a 1-to-1 scale. The fragment became a module that could be repeated to create longer and varying environments. I used clamps to hold the fabric up and plywood boards to anchor it down.